All right, let's get started with today's lesson, which is actually my second time doing this today because I deleted the first one. So today our goal is to be able to find rate of change and slope. So we're going to be doing a little bit of ratio work and looking at graphs. Here's your warm-up. All I want you to do is look at these four problems and simplify them. So find the number that goes into both that you can divide by to get a simpler fraction. So here are the numbers you could have divided each of those by to get them down to their simplest terms. And you should have got those four right. If you got all four right, come give me a high five. All right, so let's first talk about this rate of change you see on the board. And yes, I do want you to write this down. So the rate of change of a function is a ratio that compares the difference between two output values to the difference between the corresponding input values. Output is x, input is y. So rate of change really equals y value over x value. Y divided by, or x divided by y, or ratio of y over x. Have this written down and we'll do some examples. All right, so this is what we're looking for. Basically, when you're looking at a rate of change, you're trying to figure out if there's a constant change. Every single one changes at the same rate, or is it varied or a variable? Does it change? Does it go high? Does it go low? Does it mix around? So here's how you do it. You'll be given a table with your x and y values, and what you have to do is find the difference between the consecutive data points, which means find the difference between the x's, find the difference between the y's, and set up your ratio of y over x. So let's do the y's first. So from 5 to 11, that's a change of 6. That's where we get the 6 there. 11 to 20 is a change of 9, right there. 20 to 23 is a change of 3, right there. And 23 to 29 is a change of 6. That's how you get these numbers there. And it doesn't matter positive or negative because we're just looking at the absolute value change. So from 2 to 4, it's a change of 2. So we get the 2 down here. 4 to 7 is a change of 3, right there. 7 to 8 is a change of 1. And 8 to 10 is a change of 2. So now what you do is you basically find out what the value is of each ratio by dividing the x over the y. So 2 goes into 6 3 times. Now what we're going to do is make sure that the other ratios give you the same value of 3. If they do, it's constant, and you can see it does. 3 goes into 9 3 times, 1 goes into 3 3 times, 2 goes into 6 3 times. So we call this rate of change constant. Write this down before moving on. Now remember, you have to make sure the y is over the x. Be careful, that's where people usually make a mistake. They don't put the y over the x. Here's an example of one that's not constant. So if we look at the y values first, you can see from 0 to 3, that's a change of 3. This is actually a change of 2, 3 to 5. 5 to 8 is a change of 3, and 10 to 8 is a change of 2. Let me change this to plus 2. So you can see all the numbers are written down here. This should be changed to a 2. And then the x's, 0 to 1, 2, 3, 4, they all change by 1. So the denominator of these is 1, 1, 1, and 1. Now here's why it's a variable. 1 to 3 gives you 3. 1 to 2 gives you 2. 3 to 1 gives you 3. 1 to 2 gives you 2. It's switching back and forth, so it's a variable. So you would say the rates of change here are variable. So now you're able to see 2 examples. I would encourage you to write this down. And here are 4 that you can do on your own. If you want to do all 4, stop the video now. Otherwise, hold on. I'm going to do one with you. All right, so let's look at number 1. If we look at the rate of change at the top, 5 to 15 is 10. 15 to 20 is 5. 20 to 25 is 15. And 35 to 50 is also 15. Now if we look at the x, which I'll do in blue, 1 to 3 is a change of 2. 3 to 4 is a change of 1. 4 to 7 is a change of 3. And 7 to 10 is a change of 3. Now, if I look at the bottom to the top, that 2 divides into 10 5 times. 1 goes into 5 5 times. 3 goes into 5 5 times. So since all these are the same, this is constant. Okay, go ahead and do the rest on your own. And here are the answers you should have received. 2 was a variable, 3 was a variable, and 4 was a constant. Now I know you could guess 50-50 and get it right or not. That's why I want you to always show your work so I know that you understand it or you don't. So if you got these all right, come on over and give me a high five. The other half of this lesson is looking at slope. We looked at rate of change. This is the slope. Now this would be a slope line that has a rate of change of +1. Every single one was consistently +1, +1, +1, +1. When you have a rate of change that's constant, and it creates a straight line, we call that a slope. So I want you to write that down. So this slope would mean that the x and y value, or the 0 and 1, over 0, up 1, and then the value of 1, 2, and the value of 4, 5, these are all a constant slope. Write that down. Now, a constant slope also means that it's a linear function. If you get a constant slope in a straight line, that's also a linear function, which is the stuff we worked on graphing in a previous lesson. So let's take a look at how you actually can graph these things. All right, so we have a table here that shows us the driving distances that Jesse recorded. So we're looking at time over distance. So time is your x, and distance is your y. Now remember, x is the variable that doesn't change. This is the one that is always going to be constant for you. That's what we call a constant variable. So I do want you to write that down so you don't forget what the difference is. That constant is also called a independent variable. So this is independent, and that's your x, and the dependent is the y. So those are the ones that the dependent counts on the time. Dependent can change. X is usually going to be the same. Okay, so let's take a look at these and let's figure out if we can find first whether it's constant or a variable. So we have to find the difference here. 0 to 5, that's a change of 5. 5 to 10, change of 5. 10 to 15, change of 5. 10 to 20, change of 5. Distance on the top, 0 to 3 is a change of 3. 3 to 6, a change of 3. 6 to 9 is a change of 3. And 9 to 12 is a change of 3. So it's constant at a 3 to 5 ratio. Now that's just the first half. Write this down before I move on. The second half of this then is we have to put down all these ordered pairs. 0, 0, 5, 3, 10, 6, 15, 9, 20, 12 on this graph. And when we do, we're going to see that we get a straight line. So the slope of this is that rate of change we found, which is 3 to 5. So the slope is 3 to 5. So this means that he drove 3 miles for every 5 minutes. And when you graph it, just putting those points right here on the graph, we can see that we get a nice straight constant line. And if it's straight, that means the slope is the rate of change we found, which is 3 over 5. All right, your turn to solve this one. First, find the rate of change of the earnings to the hours. So you want to try to find what the ratio is. So if we're looking at hours, you want to find out how much money is made in 1 hour and see if it's constant all the way across. Once you do that, then you can graph the data. Come back when you're ready. All right, so looking at the answers here, we found that it's constant because $8.50 per hour is what she makes. So every hour is $8.50 in those total amount of hours. That's what it comes out to be. So it's constant. So our slope is we just write it as a decimal, 8.5. So because Mackenzie earns 8.5 an hour, we can graph this. At 3 hours, it's 25.50. So at 3 hours, roughly 25.50 would be there. 7 hours, 59.50. 10 hours, 85, and so on and so on. So we can see that we have a nice straight line. So that tells us that the slope is an increase of 8.5. So here we can see that it's a constant change of 8.5 for every hour. And since we're looking at money, you change that 8.5 to a money situation of $8.50. So if you got that right, good job. All right, it's time for your box of thought. 3 questions. Give it a good think. Give good answers, please. And finally, here's your lesson quiz. Good luck with your work. Can't wait to see your answers, and we'll see you next time.